Good day, everyone, and welcome back to the second session of the Diverse Node Mobility Front-End Development Program. Today, we will discuss the continuation of Module 2, and we will start the Module 3. So here, I'm going to share my screen to you. So here we end here in the slide the prefix and postfix operators and their priorities. Take a look at two simple examples here. So we have integer I and j. We have declared I and j, and I is equivalent to 1 and j is equivalent to I increment. So first, the variable I is set to 1. In the second statement, we will see the following steps. The value of I will be taken. As we use the post incrementation, the variable I will be increased by 1. In effect, j will receive the value of 1 and I the value of 2. So things go a bit differently here. Int, here's another one. So we have declared I and j. It is declared as int ij. I is equivalent to 1, j is equal to increment I. So the variable I is assigned with the value of 1. Next, I variable is incremented and is equal to 2. Next, the increased value is assigned to the j variable. In effect, both I and j will be equal to 2. Right, so that's the difference between that. Right, so look carefully at this program. Let us trace this execution step by step. So we have declared I and j for int type, and I is equivalent to 4, j is equivalent to 2 times I increment, and we have I equals 2 multiplied by decrement j. So number one, the first thing is the I variable is assigned to the value of 4. Next, we take the original value of I, which is 4, multiply it by 2, and assign the result, which is 8, to j, and assigned post increment and I variable, and now it is equals to 5. For third, uh, we decrement or pre-decrement specifically the value of j. It is now equals to 7. This reduced value is taken and multiplied by 2, and the result is 14 and is assigned to the variable of I. What else do you need to know about the new operators? Firstly, their priority is quite high, higher than asterisk and slash and modulus operators, or multiplication, division, modulus operators. Secondly, their binding depends on whether you use the prefix and postfix version. The prefix version operators have a right to left binding, while the post operators bind from left to right. Our priority table now reads as follows. So here's the updated priority table upon our progress in this module. So we have shortcut operators. It is time for the next set of assignment operators that make developers' life easier. Those described earlier deal with addition and subtraction of one. Very often, we need something other than addition or subtraction, or we want to use a value other than 1. Consider the expression below. So we have I is equals to I times 2. We can use it when calculating a series of powers of 2. So here's another example. We would use this expression. So we have sheep counter is equals to sheep counter plus 10. In the C language, there's a shortened way to write this expression. So instead of writing this expression, we can use I times is equals to, or asterisk equals to 2. Or instead of writing this one, we can have sheep counter plus equals to 10. So technically, the sheep counter and the sheep counter should be also it is always on the lowercase, since we have used in the first example a lowercase of the spelling sheep counter. Let us try to present a general description for operations. If OP or OP is a two-argument operator, this is a very important condition, and the operator is used to the following context. We have variables equals to variables, then operator, then expression. Then this expression can be simplified as follows. So we have variable, operator, then equals operation. So this is the syntax for this shortcut operator. So we have the variable, for example, we have I and equals, then another variable, and the operator, which is the multiplication and the expression. So instead of doing that one, we can have variable, then operator, which is multiplication, and then equals, and then the expression. So here's the example for the shortcut operators. Take a look at the table here. So this is example for multiplication. The second row is example for division. This one is for modulus, and this one is for parenthesis. Wait. So let's have our next slide. So the level of difficulty. Let's have easy. This is easy. The objective of this laboratory activity is to familiarize the student with fixing errors in the program, doing simple math with operators, variables, and numbers, and printing on screen. So here's the scenario. Check the program in the editor, find all the possible compilation errors and logic errors, fix them, we will fix that, but do not change any numeric values. Your version of the program must print the same result as expected output. Before you use the compiler, try to find the errors only by manual code analysis. So this is our expected output. The value of half is 0.50000, and the value of pi is 3.14, 15, and 93. All right, as you can see in the editor, if we are going to run this, it will prompt as an error. So how can we fix this? As you can see, we are going to erase this operator, since the C language always should be end on the expression or on the value if you are going to use operator. So here the plus sign is not on its place. So if we are going to run this one, we will get this answer. Right. So as you can see, we have the value, we have the output, but the its value is incorrect. So as you can see, the half value uh, should be give us 0.50000. So instead of plus, we are going to change it into subtraction, and this one, the pi, should be addition. So now let's check if it's now correct. All right, so it now prompt as the correct answer. Okay, so next, let's have the next slide. All right, so this another activity is also easy. So the objective of this laboratory activity is familiarize you, the students, with fixing errors in the program and doing simple math with operators, variables, and numbers, and also printing on screen. So we are going to also have do what we have did earlier. So check the scenario, check the program in the editor, find all possible compilation errors and logic errors. We are going to fix them, but do not change any numeric values. So your version of your program must print the same result as expected output. Before you use the compiler, try to find the errors only by manual code analysis. So this is the expected output. The value of 4 is 4, and this one is the value of 5 is 5. So if we are going to print this, so it will you will get an error. So how to fix this? Okay, so let's check and analyze the logic of the program flow. All right, so since this one, we are going to uh, delete this one here and put a plus sign here, and this one is we are going to change it by plus sign. So let's try if we are going to get the right answer. All right, so we have the right answer here. So that is how we analyze the errors in the simple mathematic logic in the C language. Right, so let's have another. Let's have the next slide. All right, so this I think this slide is also another activity, laboratory activity. Right, so this one is also easy. Right, so let us familiarize the fixing errors in the program, doing simple math with operators, variables, and numbers, and also printing on screen. So we have the expected output written below. To check the program, the editor, find all possible compilation errors, logic errors, fix them, do not change any numeric values. Your version of the program must print the same result as expected output. Before you use the compiler, try to find the errors by manual code analysis. So we have 10, the value of 10 is 10, and we have 6 zeros, so this is a float, and we have the value of 12 is equals to 12.6 zeros. All right, so let's analyze this code in the editor. So what do you think is the answer here? So the instruction is do not change the numeric value. So we are going to decide what operators should be used in this. So I think we should have multiplication. 2 times 3, so that is equivalent to 6, and then plus 4, so that would be equivalent to 10. All right, so let's have the 12 value. How about this one? 3.5. All right, so we have how about the 12 value? So all right, so I think we are going to put here multiplication operator, and here is another multiplication operator, and here is a plus. Okay, so we are going to check if we have the correct answer. Right, so we got the correct answer here. Okay. Okay, so this one is another easy laboratory activity, and we have the same objectives earlier, and we have the same direction, which is do not change the numeric values, but we have to check the logic errors. Okay, so the expected output for this activity is here in this snippet. The value of 10 is 10, the value of 20 is 20. So this is a int type. Okay, so let's have the first variable. What do you think is the answer here? All right, so I have my own example here and getting that output. So I just add multiplication here, and then that will be equivalent to 24 and then minus 14. So we will have the answer 10, and I just erase the value written here, just 10 and 5, and from that I will get the value of 20, because 10 value variable is equal to 10, and the 2, and it will be multiplied by 2, and so we will have the value of 20. So if I'm going to run this one, I will get this output. All right, so let's have another one. Okay. All right, so this is another activity. So we will have the same objective, the same scenario, but this is the expected output. So the value of 8 is 8. So here, as you can see, take a look in the editor, the code in the editor, analyze the compilation errors and the logic errors. Right, so in this example, I will remove 10 and 5, since the x value will result as 4, since 4 times 6 is equals to 24, and divided by 5, and we will have the remainder 4. And then here, so 4 times 2 will have 8. Right, so I'm going to run this program, and we will have the same, the expected output. Right. All right, so here's another laboratory activity. So we have the objective using operators to familiarize with students with operators, building simple expressions, translating verbal description into programming language. So we have the scenario. Take a look at the code we have provided in the editor. It assigns two integer values, manipulate them, and finally outputs the result and big result variables. So the problem is that the manipulations have been describing using natural language, so the code is completely useless now. So we want you to act intelligent naturally, compiler, and to translate the formula in the real C code notation. Test your code using the data we have provided. So the expected output is result 838, and the big result is 54872. All right, so we have increment x value by 3, in decrement y value by x value, multiply x value times y value, giving the result decrement result by 1, assign assign result modulus result to y value, and then we have increment value result by result added to x value, assign result times result to big result, and then we have increment result by x value times y value. So we are going, so since this is a comment, we are going to translate it to the formula into C language notation. So take, all right, so for the first line, we have increment x value by 3. So we have here x value plus equals to 3. So that is the increment x value by 3. That is how we write them. All right, so how about decrement y value by x value? So this is how we write them. Y value minus equals x value, right? So how about multiply x value times y value giving result? Okay, so we use the variable result here and multiply the x value and y value. So that is result equals x value times y value. How about the next one? Increment result by result. Okay, so we have result plus equals result. Okay, how about decrement result by 1? So this is result minus minus. And how about assign result modulus equals, result to y value. So this is how we write them. Y value is equals to result, then modulus result. Right, so how about increment result by result added to uh, x value? So that is result plus equals x value plus result. Okay, how about assign result times result to a big result? So how to get that is result. We have the variable result, and we have assigned result by result uh, times result times result. So that is three results, multiplication of three result variable. How about the last statement? We have increment result by x value times y value. So that is result plus equals x value times y value. So we are going to write those operators or the expression above the printf, since that would be the initial op- operation on how to get those outputs. Okay, so we are going to run this program. All right, so we get the same result as expected result. Right, so let's have the next slide. Okay, so this one is also easy. So let us familiarize the fixing errors in the program, doing simple math with operators, variables, and numbers, order of operations, used of parentheses to change the order of operations, and we have to print on screen. So we have the scenario, check the program in the editor, find all possible compilation errors and logic errors. So let us fix them, but do not change any numeric values. Right, so however you may use for parentheses, you can add them or remove them. Your version of the program must print the same result as the expected output. But before you use the and try the errors only by manual code analysis. So we have we are going to add or remove, but do not change or alter any value or any variables in the program. So the expected output for this activity is the result is 28 and the big result is 59. So we first analyze the editor, and as we run this one, we will get the error. Okay, so as you can see, the console expected the closing parenthesis. So let us check. Okay, so we are going to have the closing parenthesis here because it will prompt as an error. All right, so how about running this program? Okay, so we are correct in the first statement result, which is 28. And how about the big result is equal to 84? So this is wrong. We are uh, going to make that 59. So how to do that? Since we are getting a result here, I think we are going to add, instead of times, let us make it plus. Instead of Right, so instead of this one, we are going to use multiplication. Right, so we have 51. So the direction also says us that we can remove and add. So since 51, it is close to 59, we are going to add 8 here. Right, so in this one, we have the expected output, which is the result is 28 and the big result is 59. All right. But if you are going to use a different expression, but we will have the same result, it is okay. Okay, how about this activity, laboratory activity? Right, so we have here to the objectives is to fixing errors in the program, doing simple math with operators, variables and numbers, order of operations, use of parentheses to change the order of operation, and printing on screen, which is printing the expected output. Right, so we have the same direction. Do not change any numeric values, but we can add and remove them. All right, so the expected output here is the result of 20. The small result is 5. So if we are going to run this program, all right, so we have, all right, as you can see, this statement here, we don't have an opening parenthesis. Okay. So now we have, we are getting now the result, but the value itself is incorrect. So we are going to change or correct the algebraic errors. So I'm going to change these operators. Okay, so if you analyze this one, we are getting the result of 24. So I'm going to have -4 here. And now let us try. All right, so I get the result is 20. But here in the small result, I haven't uh, analyzed and changed the operators. All right. All right, to make it easier, I'm going, since we are getting 8 here, so I'm going to have -3. Okay, so this result is 20 and the small result is 5. Okay, so how about the next one? Okay, so the level of difficulty of this activity is easy, and the objective for this one is fixing an error, doing simple math with operators, variables, and numbers, order of the operations, and use the parentheses to change the order of operations. So we have to print this on screen, and we can add and remove uh, them, but we cannot change. So the expected result for this one is the result is 4, the small result is 7. So if I'm going to run this one, okay, so uh, we don't have us closing parenthesis here in this part. Okay, another error is, okay, so as you can see here, the small result having the element or the space, since we have declared that we don't have space here. Okay, so a reminder that if we are going to make a variable instead of space, just add underscore. Okay, so we are getting now the result, but we don't have the right answer in the first part, which is 1 instead of 4. Okay, so we are going to change the result. Okay. Right, so to make this easier, I'm going to add +3. All right, so now we now get the expected output. All right, so this is another lab, and we have the scenario. Complete the program in the editor, compute the accrued amount of money with starting value of 100 and annual interest rate of 1.5%. Compute the and print the result for the first 3 years. Your version of the program must print the same result as expected output for each year. Compute each annual value on the basis of previous year's value. So the expected output is after first year 101.5, after second year 1.03.02, after third year 104.54. So here, if I'm going to run this program, okay, so we don't have any operators that we use. So here, after this comment, we are going to print our code here. Okay, please analyze. And all right, guys. So I have my own code here, and uh, before getting the result of this, you are going to create your own code. So for me, I assign the first value, year value variable to start value, which is 100, plus the start value, which is 100 times interest rate, which is this one. So it will result as 101.5. And for the second year, start value plus, and it should be, since this is the second year, I added times 2, and for the third year I added times 3. But this code will result only uh, the 1 point. For the second year it will just result 1.3.0 and 1.4.5, but it is on the same track and the same logic, but it doesn't have the exact amount or the exact floating point. All right, so let's have the last laboratory. All right, so this one we have to familiarize the operators, shortcut, and pre-post decrement operators, building simple expression, and the translating verbal description into programming language. So take a look at the code we've provided in the editor. It assigns two integer values and manipulates them. Finally outputs the result in big result variables. So the problem, the manipulation have been described using natural language, so the code is completely useless now. So we want you to act intelligent compiler and to translate the formula into real C code notation. Is the same code as the one we provided in one of the previous labs. But this time, try to use pre-post and shortcut uh, operators. They fit perfectly into some of the steps. Test the codes using the data we have provided. So the expected output is result 38 and big result is 54872. The first statement says increment x value by 3. So I'm going to write x value, then increment by 3. Okay, so decrement value by x, okay, decrement y value by y value, by x value, I mean. Then don't forget the semicolon, multiply x value times y value, giving the result x value times y value, giving the result. Okay, so this is how we do that. And don't forget the semicolon. Right, so how about increment result by result? So we have to increment result by result. Okay, And how about decrement result by 1? Or decrement result by 1. Okay, assign result. So we are going to assign result modulus result to y value. Okay. The next one is increment result by result added to x value. Increment result by result added x value. Okay, next one. Um, assign result times result times result. Okay, so this is big result. And then increment result by x value times y value. Okay, so if I'm going to use this, I'm going to run this program. I will get the expected output here. So result 38 and big result is 54872. All right, so let's have the next slide. All right, so here's the next slide. We have the char type. Okay, so here's another characters as another kind of data. So far, we have treated the C language as a tool for performing calculation on numbers. This is consistent with the common belief that the computer is just a smarter calculator. But you know, this isn't a nature, as the computer can be easily used for word processing too. All right, so we can define a word as a string of characters. So letters, numbers, punctuation marks, and etc. We dealt with the strings during the first lesson when we used the puts function to write some text on the computer screen. Now, however, we were going to ignore strings consisting the multiple characters and focus our attention on single characters. The problem with processing strings, though, will come back to haunt us when we start working on arrays, because the C language all strings are treated as arrays. To store and manipulate the characters, the C language provides a special type of data. This type is called a char or char, which is an abbreviation of the word character. Let's try to declare a variable for storing a single character. So we have the char type. Char, then characters is the variable. Looks familiar, doesn't it? Now let us say the first words about how computers store characters. Okay, so let's have code. Computers store characters as numbers. Every character used by a computer corresponds to a unique number and vice versa. This system of assignments includes more characters than you would probably expect. Many of them are invisible to humans but essential for computers. Some of these characters are called white spaces, while others are named control characters because their purpose is to control the input-output devices. An example of a white space that is completely invisible to naked eye is a special code or a pair of codes. Differently, operating system may treat this issue differently. Okay, it will depend on the operating system, which are used to mark the end of the lines text files. People don't see these signs, but they can see their effect where the lines are broken. We can create virtual any number of assignments, but a world in which each computer type uses different character encoding would be extremely inconvenient. This has created a need to introduce a universal and widely accepted standard implemented by almost all computers and operating system all over the world. AXI, which is short for American Standard Code for Information Interchange, is the most widely used system in the world, and it is safe to assume that nearly or all modern devices like computers, printers, mobile phones, tablets, etc., use this code. The code provides space for 256 different characters, but we are only interested in the first 128. If you want to see how the code is constructed, go to the table on the right, look at it carefully. There are some interesting facts about it you might notice. We will show you one. Do you see um, what the code is? The most common character is the space. Yes, it is 32. Now look on the code on the lowercase a is it's 97, right? And now let's find the uppercase A. Its code is 65. What's the difference between the code of A and A, capital A? It's 32. Yes, that's the code of the space, and we will use that interesting feature of the AXI code soon. Also note that letters are arranged in the same order as in Latin alphabet. So for the example, we are going to find small a, which is 97, and the big A is 65, and the space is 32. So the difference between that is 97, which is equivalent to lowercase a, and 65, which is equivalent to uppercase A, is 32, which is space. Okay, let's have this next slide. All right, so this one, the char type values, how do we use the values of char type in the C language? We do it in two ways, which are not entirely equivalent. The first way allows us to specify the character itself, but enclosed in single quote or apostrophes. Let us assume that we want the variable we declare a few slides earlier to be assigned the value of the uppercase letter A. We do this as follows. Character is equals to single quotes A. We're not allowed to omit apostrophes under any circumstances. Now let's assign an asterisk to our variable. We do this as follows. Character is equals to single quotes and then asterisk. The second method consists of assigning the non-negative integer value that is the code of the assigned character. This means that the assignment below will put an A or capital the uppercase A into the character variable. Character is equals to 65. So the second solution, however, is less recommended, and if you can avoid it, you should. Why? Firstly, because it is illegible. Without knowing AXI code, it is impossible to guess what that 65 really means. Perhaps this is the code for a character, but it can also happen that sociopathic programmers using this devious way to save the numbers of sheep that have already been counted. The second reason is more exotic, but it is still true. There is significant numbers of computers in the world which use codes other than AXI. For example, many IBM mainframes use the code commonly called EBCDIC, or stands for Extended Binary Coded Decimal Interchange Code, which is very different from AXI and is based on radically a different concept. All right, so we have the AXI code and we have the EBCDIC. So here's the hexadecimal code, and this is how we the equivalent of hexadecimal is equivalent to T in EBCDIC, and AXI is this symbol. So there are different equivalent in different code, just like AXI and EBCDIC. Okay, let's have the next slide. this slide talks about ASCII versus EBCDIC. Now imagine that you've written a wonderful program and decided to compile and run it on a computer utilizing the EBCDIC code. If you write something like this, character is equivalent to single quote. Instead of that is question mark. The compiler running on this program, that computer would notice the question mark and use the appropriate ABCDIC code for that character. But if you wrote it like this, character is equals to 63, you wouldn't give the compiler a chance to guess what your intention was. We can assure you that 63 certainly does not represent a question mark in the EBCDIC code in literal. Now, probably a good time to bring a new term in the mix. A literal. A literal is a symbol which uniquely identifies its value. Some prefer to use a different definition. The literal means itself. Choose the definition that you consider to be clearer and look at the following simple examples. So the first one is character. This is not a literal. It is probably a variable name. When you look at it, you cannot guess what the value is currently assigned to that variable. And the second one, we have a single apostrophe, then a. This is a literal. When you look at it, you can immediately guess its value. You even know that it's a literal of a char type. Then next one is 100. This is a literal too of the int type. Let's have 100.0. This is another literal, this time of a floating point type. Okay, let's have I plus 100. This is a combination of a variable and literal joined together with a plus operator, and this structure is called expression. So if the two literal is combined, which is I, and then we have operator here and another literal, that is called expression. Okay, let's have character literals. If you are inquisitive person, you probably want to ask a question. If a literal of a type char is given as a character enclosed in apostrophes, how do we code the apostrophe itself? The C language uses a special convention which also extends to other characters, not only to apostrophes. Let us start with apostrophe anyway. The correct format looks as this follows. So the character is equals to, this is the apostrophe and the apostrophe itself. So we are going to put a backslash in the front of the apostrophe to give the output a single apostrophe. So the backslash character acts the escape character because by using the backslash, we can escape from the normal being of the character that follows the slash. In this example, we escape from the usual row of the apostrophe, which is delimiting the literals of a type char. You can also use the escape character to escape from the escape character. Yes, it does sounds weird, but the example below should make it clear. This is how we put a backslash into a variable of the char of the type char. So we have the apostrophe for the literal, and we have the backslash, which is stands this the first backslash is the escape, and this one is the symbol itself. So let's have escape characters. The C language allows us to escape in other circumstances too. Let's start with those that denotes literals are representing white spaces, backslash n. So this one denotes a transition to a new line and is sometimes called an LF or line fade, as printers react to this character by pulling out on the paper by one line of text. So how about backslash R? So this one denotes the return at the beginning of the line, and sometimes called CR or carriage return. Carriage was synonym for print head in the typewriter era. Printers respond to this character as if they're told to restart printing from the left margin of the already printed line. How about backslash A, as in alarm? This is a relic of the past when teletypes were often used to communicate with computers. So sending this character to a teletype turns on in its ringer. Hence, the character is officially called BEL, as in bell. Interestingly, if you try to send the character to the screen, you'll hear a sound. It won't be a real ringing, but rather a short beep. The power of tradition works even in the other world. How about backslash zero? So note that the character after the backslash is a zero, not a letter O, called null. From the Latin word nullus means none, is a character that does not represent any character. Despite first impression, it could be very useful. As we will show you in the lessons to come. Now we will try to escape in a slightly different direction. The first example explains the variant when a backslash is followed by 2 or 3 octal numbers. A number coded in this manner will be treated as an AXI value. It may look like this. A character is equals to backslash 47, and this is enclosed by single apostrophe. Oh, okay. So the next one is 047 octal is equivalent to 39 decimal. Look at the AXI code table and you will find that this is the AXI code of an apostrophe. So this is equivalent to the notation. A single apostrophe, then backslash is equals backslash apostrophe, but only for computers implementing the AXI code. All right, so we have backslash 47 and backslash apostrophe. So they have the same meaning and it will prompt us apostrophe. So this one is an octal number, and this one is the symbol itself, and we just use escape operator, which is a backslash. So the second escape refers to the situation when a backslash is followed by the letter X in the lowercase or uppercase. It doesn't matter. In this case, there must be either 1 or 2 hexadecimal digits, which is treated as ASCII code. Here's an example. So we have characters equals to single quote backslash X 27. As you've probably guessed, 27 hexadecimal is 39 decimal. Okay. Okay, so the char values are int values. There's an assumption in the C language that may seem surprising. At first glance, the char type is treated as a special kind of int type. This means that first, you can always assign a char value to an int variable. Second, you can always assign an int value to a char variable, but if the value exceeds 255, the topmost character code in the AXI, you must expect a loss of value. So the value of the char type can be subject to the same operators as the data type int. We can use this using a simple example. We said earlier that AXI, the distance between upper and lowercase letter, is 32, and that 32 is the code of space character. Look at this snippet. So we have the char type char, and that char is equals to apostrophe a, and the char plus equals 32 or increment by 32, and char decrement by space. This sequence of subsequent addition and subtraction will bring the char value to its original value A. You should be able to explain why. All right. So now look at the assignment below. They are all correct. By try to interpret their meanings, this should be a good exercise for you. So we have the char is equals to A plus 32. Char is equals to A plus plus space, and char is equals to 65 plus space and 97 minus space, and we have this one lowercase minus 32 character a lowercase a minus space. Okay, so we have the result 3 lowercase a and uppercase a. Okay, so now you can explain why did we get those outputs. Okay, so let's have the next slide. Okay, here's another laboratory activity. So the objective for this one is to familiarize the characters types and the values, fixing in errors in the program and printing on screen. So the scenario would be check the program in the editor, find all the possible compilation error and logic errors, fix them, but do not change the any character values, and your version of the program must print the same result as expected output. So the output is diff between C and A is 2, and diff between A is and C is negative 2. So here we don't have we get an error, compilation error. Okay, so now let's find the code here. We are going to, so here I write my own program code here. So first I declared the character C and A, since that is the two character that we will use in the program, and the next one is integer, which is this one, the variable for 2 and negative 2. So I have difference, and the next one is diff 2. So I create an expression here, which is diff is equals to apostrophe C minus A, and diff 2 is equals to A minus C with apostrophe. So after that, the I add the C and A, which is this one. This would be the first the variable that will appear here, which is C. So I put here after the double quotes, and the next one is A. Every character that you will use, you will add single quote, and since this is an integer, so we don't have a single quote. So I just add the diff variable here, so here, and just like the second one, so we have difference between so the scan for character is after percent %c, and since the character A is the first character that will be coded in the expected output, so I put A here, and next one is C, and the integer for this is diff2. So I'm going to run this program, and it will prompt us the same result as expected output. All right, so let's have the next slide. So here's another activity. The objective of this activity is to familiarize the character types and the values, fixing errors in the program and printing on screen. So the scenario for this one is check the program below, find all the possible compilation errors and logic errors, fix them, but you may not change any character values. You may change variable names. Your version of the program must print the same result as expected output. Before you use your compiler, try to find the errors only by manual code analysis. So here's the expected output: uppercase letters between and with Z and A is 26, and lowercase letters between and with Z, lowercase Z and A is 26. So we have here this code, and if we are going to try to run this program, it will prompt us the wrong or the compilation error. The first thing to do is to we'll be right back and create my own code. Okay, so take a look here in the printf. So this is the first line for the expected output, uppercase letters between A. So we have the same here, but here's the character represent. So this must have the uppercase Z. So the uppercase Z is equivalent to the last letter variable. You check the cases of the variable. That's right. Okay, this next one is uppercase A. So that is equivalent to first letter. Okay, first letter. So we are going to remove this small letter. Okay, so the next one is D, so this is an integer. So what we are going to do is create or declare an integer. So this, I will name it as difference between. So this is diff and diff2. Okay, so we are going to declare a formula for this, which is diff is equals to um, last letter minus first letter. Okay, so here let's add semicolon and last letter first letter 1. So we are going to erase this and add the diff variable. Yeah, but the next one we have lowercase letter between, and so we have so the expected output is lower z. So where's the lower z? And that is equivalent to last small letter. Okay, right. And the next one is %c. So that is equivalent to small letter a, which is first small letter. Small letter. Okay, this is right. And we are going to erase this and add diff2. Okay, so before I forgot, we are going to declare the expression or the operators that we will be used, or the value to be get the value of diff2, which is last small letter minus first small letter. Okay, so now let's check the result. All right, so if we are going to run this program, we will get the result 25 and 25. So in this case, if it is 25, we are going to add 1 here. We can put the +1 either in printf or in the declaration of the operators or the formulas. So here's, if we are going to run this program again, so we will get the expected output, right? So let's have the next slide. Okay, so objectives is to familiarize the character types and values using characters types, but practically and printing on screen. So the scenario is write a small program which prints the difference between all 10 digits characters from 1 to 0 and 0. From 1 to 0 and 0, print each one of the separate line. Your program must print the same result as the expected output. So here's what we will get. Okay, 1 is equal 1 minus 0 is 1, then 2 minus 0 is 2, 3 minus 0 is 3, right? So first thing to do is the character 0. Okay, so we are going to also create integer. Okay, so we have 1 is equals to 1. 1 is equals to 1. I've declared another character type from 1 to 9. Okay, so don't forget the semicolon. And we are going to have the printf. Okay, so the printf would be this one. All right, so we should enclose this to single quote. So we have percent C, since this is a character, minus single quote. Okay, so we are going to try the first line and just copy paste if it is right. Okay, so is, okay, so now we are going to declare the variable that we will be using. So forgot to have the int type. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 result, and I will rename them R1, R2, R3, R4, R5, R6 until 10. Okay. So the data types that we will be using here, or the variables that we are going to use here, is one, which is 1. We rename that as 1, and 0, and R1. So let us check if we are going to get the result. All right, so, oh, forget the T here. Okay, let's check what's wrong here. Okay, so percent D. I forgot the comma. Okay, how about now? All right, so we got the number 1 minus, but the thing is we don't have the formula. So all we need to do is get the formula, or create the formula. Okay, so the thing is R1 is equals to 1 minus 0, and then we will have semicolon. Okay, so let's check the first line if we get this right answer. So we have the right answer here. Okay, right. So it is now time to copy paste the lines respectively. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is 2, 3, 4, sorry, 4, 5, 6, 7, 8, 9, and 10. And 2, 3, 4, 5, 6, 7, 8. Be careful to your spelling, or even the cases of the variables, and then 10. Okay, and don't forget the printf. It will not print if you wouldn't do that. Okay, so we already done with the formulas, and let's have the print. So we are going to paste 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? Also, don't forget the integers of the result. Seven, 8, 9, and then 10. All right. So we are going to run this if we are correct. We got some compilation error here. R4, R3, undeclared. Error, R3, 3. Okay, let's check. All right, so the error earlier was I wasn't declare the 10 here, and I forgot this is 0 minus 0. So uh I just add int 10 and remove the int here, and directly declare the integer, and after that get also declare the formula. So here, well, if I'm going to uh, play run this one, I will get the uh, right result. But as you can see, it will print us in a straight line because we don't declare any backslash n, which stands for new line. So I'm going to add new line here after that %d. Okay. Okay. So now let's check. Okay, so this time it will prompt us the correct answer. Okay, so let's have the next slide. Okay, so one who asks does not an error. A programmer writes a program and the program asks question. A computer executes the program and provides the answers. The program must be able to react according to the answer it receives. Fortunately, computers know only two kinds of answer. Yes, this is true, or no, this is false. You will never get a response, I don't know, or probably yes, but I don't know for sure. To ask question, the C language uses a set of very special operators. Let's go through them one by one, illustrating their effects using some simple examples. We have question is x equals to y. Question are two values equals. To ask this question, you use the equal operator or x equal y. So this is example. Don't forget this is important distinction. So equal is an assignment operator and equal is a question. Are this equal? Okay, so that is question. So equal is a binary operator with a left side binding. It needs two argument and checks if they are equal. Now let us ask few more questions, try to guess the answer. So 2 equals 2. So this is simple. Of course, 2 is equals to, the computer will answer true. So 1 equals 2. The ones, this one is simple too, the answer will be false. I equals to 0. Note that we cannot know the answer if we don't know what value is currently stored in variable I. If the variable has been changed many times during the execution of your program, the answer to this question can be given only by the computer and only at the runtime. Okay. Okay, so is another question. Is X equals to Y? There's another developer who counts white and black sheep separately and falls asleep only when there are exactly twice as many black sheep as white ones. The question will be as follows. Black sheep counter equal 2 times white sheep counter. Due to the low priority of equal operator, this question shall be treated as equivalent to this one. Black sheep counter equal. Then we have parenthesis 2 times white sheep counter. Question: is X not equal to Y? To ask this question, we use exclamation equal. It's a very close relative of the equal operator. It's also binary operator and has the same low priority. Imagine that we want to ask either the number of days left to the end of the world is currently not equal to 0. Days until the end of the world not equals to 0. The answer is true. Gives us the chance to go theater or visit our friends. Question: is X greater than Y? You can ask this question by using greater than operator. If you want to know if there are more black sheep than white ones, you can write it as follows. The answer is true. Confirms the statement. The answer false denies it. Black sheep greater than white sheep. Another question. Is X greater than or equal to Y? The greater than operator has another another special non-strict variant, but it is denoted differently in classical arithmetic notation. Greater than or equal. There are two subsequent signs, not both. Both of these operators, strict or non-strict, as well as the other two that we discuss in the next section, are binary operators with left side binding, and their priority is greater than the ones indicated by equal, and not equal. If we want to find out whether or not we have to wear a warm hat, we ask the following question. Centigrade outside, greater than equal or 0 greater than or equal 0.0. Okay. So here's another question. Is X less than or equal to Y? As you've probably already guessed, the operators we use in this case are less than operator and its non-strict sibling, less than or equal. Look at this simple example. We are going to check if there's a risk that we will be fined, but by the high police, or the first question is strict, the second is not. Current velocity less than 110. Current velocity less than or equal 110. How to use the answer we got. What we can do with the answer we get from the computer, there are at least two possibilities. First, we can memorize it or store it in a variable and make use of it later. How do we do that? Well, we would use an arbitrary variable of type int like this. Int answer 1, value 2. Answer equals value 1 greater than or equal value 2. If the answer is true, because value 1 is greater than or equal to value 2, the computer will assign 1 to answer variable. If value 1 variable is less than value 2 variable, the variable answer will be assigned to 0. So here's an updated priority table. The second possibility is more convenient and far more common. We can use the answer to make a decision about the future of our program. We use the special instruction for this purpose. We will tell you what that is very soon. Now we need to update our priority table. It now looks as follows. So this is the priority table. So we have the unary and binary. So we have conditions and conditional execution. You already now know how to ask, but you still don't know how to make reasonable use of the answer. We must have a mechanism which allows us to do something if a condition is met and not to do if is not. It is just like in life, we do certain things and we don't when a specific condition is met or not. uh, Example, we go for a walk if the weather is good or stay at home if it is wet and cold. To make this decision, the C language has a special instruction. Due to its nature and its application, it is called conditional instruction or conditional statement. There are several variants of the conditional instruction. We will start with the simplest and slowly move on the most to the more difficult ones. The first form of the conditional statement, which you can see below, is written very informal and but figuratively. So this is called if conditional statement. So we have if, then parenthesis, true or not, and do this if true. So that would be the syntax for if conditional instruction or conditional statement. So if true or not, do this if true. This conditional statement consists of the following strictly necessary elements in this and this order only. First one, if is the keyword. The if is a reserved keyword. Then left opening parenthesis, an expression, a question or an answer whose value will be interpreted solely in terms of true and false. Next one, right or closing parenthesis, an instruction, only one that we will know how to deal with that limitation. How does this statement work? If the true or not expression enclosed inside the parenthesis represents the truth, example, its value is not equal to 0, the statement behind this condition. Do this if true will be executed. If the true or not expression represents a falsehood, the statement behind this condition is omitted and the next executed instruction will be the one that lies after the conditional statement. In real life, we often express a will. If the weather is good, we will go for a walk. Next, we will have our lunch. As you can see, having the lunch is not a conditional activity and doesn't depend on the weather. What luck. Knowing what conditions influence our behavior and assuming that we have the parameterless functions go for a walk and have lunch, we can write the following snippet. If the weather is good, go for a walk and have lunch. As we already know, our friend the developer falls asleep when he counts 120 ships. His sleep is implemented as a special function named sleep and dream. And this function does not require any parameters. We can read it as if ship counter is greater than or equal to 120, then fall asleep and dream. We have said that there may be only one statement after the if statement. When we have to conditionally execute more than one condition, we need to use curly braces, which create a structure known as the compound statement or block. The block is treated as a single instruction by the compiler. This is how we circumvent the if statement limitation. Let us treat our programmer a little nicer. If ship counter is greater than or equal to 120, then this is the um, code itself. Make a bed, the name of the function. Take a shower, sleep and dream. So feed the sheep dogs. Okay, so now it's time to stylistic remarks, writing blocks. One after other is, of course, syntactically correct, but very inelegant. It may cause the text of our program to run outside the right margin of the editor. There are few styles of coding the blocks. We won't try to argue that some of them are better than others, but we will use the K and R style. The K and R styles Ah, the Kieran style are the initial of the creator of the C language, Mr. Kernighan and Mr. Ritchie. They represent this style in their classic book and we will follow it. The same snippet written in accordance with the K&R style will look as follow. So they have the same but a different format. It is K and R style. So if ship counter is greater than or equal to 120, make a bed, take a shower, sleep and dream, and feed the dogs. Due to the conditional executed block is indented, it improves the readability of the program and manifests its conditional nature. In the next section, we are going to discuss another variant of conditional statement which also allows you to perform an action only when the condition is not met. Now feed your dog. Now feed your sheep dogs, please. They have been waiting ages for your attention. Right. Okay, so we have a laboratory activity here. The objective of this activity is familiarize the condition and conditional execution, fixing errors in the program, printing on screen, and the scenario is check the program in the editor, find all the possible compilation errors, logic errors, fix them, and try to find proper condition for all the three statements. Your version of the program must print the same result as expected output. Before you use the compiler, try to find the errors only by manual code analysis. So the expected output would be the first condition is true and the third condition is true. Okay. So if we are going to run this program to let us see to check what is wrong with the program or with the code. So it is said that uh, we are expecting closed parentheses. So the thing is, we don't have any operator between a and 9. So to make this true, we are going to greater than or equal. Okay. So to make this false, we are going to equals. And to make this third condition is true, so that would be equals. Okay, so let's check if it is right now. Okay, so for the first condition is true and the third condition is true. So in this program, we don't run the second condition since this is false, right? So if the condition is false, it will not print at all. Okay, so let's have the next one. So here's another laboratory activity, and the objective of this one is to familiarize the condition and conditional execution, fixing errors in the program, printing on screen, and the scenario would be write a small program which prints the absolute value of a given number. If the number is less than 0, next it would print the value of the given number on a separate line. Your program must print the same result. Okay, so this is the expected output. So for the absolute value of -3 is 3, and the value of n is n. So all we need to do is first write our code. So initially, the program we have a given integer n is equals to negative 3. So I'm going first to have printf. Okay, and I'm going to write the absolute value of what is that integer percent d is okay, so 3. So another integer. So next one is to declare it after the comma the variables. So the variable is n, which stands for the absolute value. Oh no, that would be the value, and the absolute value. So I'm going to write AV. Okay, so here I will also add AV. And let's have the formula or the expression. Okay, so the absolute value of -3 is 3. So I forgot, guys, that this is a if statement, if conditional statement. So I add if here, if n is equals to -3, then the value then it will print the absolute value of -3 is 3. So the value of, so since the second statement is not um under the conditional statement, then it will just print this one. So I'm going to print f. Okay, is -3, or if you would like to write first D, then N. So let us check if it is right. Okay, another error. Okay, guys, I just forgot the single quotes here. Okay, so I'm going to print this. The absolute value of -3 is 3. The value of n is equals to -3. So all we need to do is add a next line. Okay, so going to reset the console and check if it's right. Right, so we get the expected output. Okay, let's try this laboratory activity. The expected output is the day of the week is Monday. So let's have if statement, right? So if day of the week is equals to 1, then we are going to print okay, so I'm going to run this program and it will prompt us the day of the week is Monday. So in the other activity, it will maybe it will prompt you as the 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 name of the day of the week. Then then we can add if day of the week is equals to 1, then the day of the week is Tuesday, and so on and so forth. Okay, so let's have the next activity. Okay, okay, so this is another lesson, input and output. Now we are going to set aside conditional statements for a while and spend some more time to two important, extremely useful feature we use to provide connectivity between the computer and the outside world. Sending data in the direction from human to the computer program is called input, and the stream of data transferred in the opposite direction, example from computer to the human, is called output. You have been already learned about one function which serves to output data, but can you remember its name? Yes, it's the puts function, and we use it in the very first program we wrote, the C language. The puts functions capabilities aren't really all that stunning. It can write a string on a computer screen and nothing else, but must not use it if you want to print an integer value or a single character. Why? Because of impairment of the puts function, its argument can only be a string, or more precisely data of a type char asterisk, but don't be confused by this. We are going to tell you more about it soon. No other parameter will be accepted, so the compiler will be unrelenting and it will not compile such a program. So what should we do is if we wish to output a value of type int or float or char, output. To accomplish this and even more complex task, there is a very powerful function in the C language named printf, print formatted. This function can easily output several values of different types and mix them with the text. We cannot show you all of these capabilities now because firstly there are many, and secondly we still lack some theoretical foundation to understand many of them. The printf function has several unique features. It doesn't specify how many arguments must be provided. The only requirement is that there must be at least one argument. Additionally, only the first argument has a strict type. All subsequent argument may be of any type. Isn't sorcery. The C language enables us to write these functions ourselves. The first mandatory argument is called the format. It is the recipe of the or the specification according to which printf function will be proceeded, and with its subsequent argument. Printf reads the instruction carefully and learns from it which data is to be printed and how it should be presented to the user. Let us look at it in a few applications. The first is simple. We tell printf to print some text. We do it like this. Printf, this is just a text. C. Now the printf function is invoked with two arguments. The first is the format, the second is the variable of type int. Take a look of the format. There is a suspicious character there, and this is a percent. What is the mysterious percent intended for? If there's a percent symbol inside the format, the printf consider it a hint on how to proceed with the arguments following the format. The first hint refers to the first argument after the format, the second to the second, etc. But there are some exception to this simple rule. The percent joined together with some other characters is sometimes called specifier. In the example here below, the format contains one specifier, %d, printf, then ship counted so far, %d ship counter. The letter D indicates the corresponding argument should be treated as a value of type int and sent to the screen as a number. So D is for integer. Let's have a look at the abbreviated list specifier now. The complete list is much more exhaustive, while the general form of the specifier is far more complex and gives more opportunities to deal with the look and shape of the data presented. So let's have %d as a decimal. Specifies that the corresponding argument is a value of type int and should be presented as a fixed point decimal number. It is a synonym. Its synonym is %i specifier as in integer. So let's have %x as in hexadecimal. Specifies that the corresponding argument is a value of type int and should be presented as a fixed point hexadecimal. %o as in octal specifies the corresponding argument is a value of type int and should be presented as a fixed point octal number. It's a %c as in char specifies the corresponding argument is a value of type int or char and should be presented as a character. %f as in float specifies the corresponding argument is a value of float and should be presented as a single precision floating point number. %lf specifies the corresponding argument is a value of type double and should be presented as a double precision floating point number. Note, do you remember the difference between float and double? You probably remember that the main difference is a precision, and the double is a double that the size of the float and the size of float is 4 bytes, while the size of the double is 8 bytes, which means double has a higher precision than the float, but it also takes up more memory and is slower. You may ask how to display the % sign itself if this character is treated as the start of the specifier. The answer is perhaps not all that obvious. In this case, you need to write two %signs side by side. We can also consider it because a specifier, so let's add it in our list. %% as itself specifies the %sign. Right? So this is the different types of specifiers. Okay, take a look at this example in the editor. The printf function performs the following work of us. First, analyzes the format, and when it doesn't encounter any specifiers put the string, the year is on the string. At this point, printf encountered a specifier and learns from it that there's an integer type which should be displayed as a decimal number. It retrieves the first argument after the format, and the screen shows the number 2012. Printf resumes the reviewing the format and displays the string. The radius is denoted as. Next, another specifier is met. This time, one which demands the program is to display the value of type char as a single character. The character is taken from the second argument after the format varchar, and the character R is displayed. Printf resumes from reviewing the format and displays the string, while pi is equals to, and the next and last specifier requires it to display a float value which is taken from the third argument after the format var float. In effect, the following string will appear on the in the screen. The year is 2012 and the radius is denoted as R, while pi is equals to 3.141500. So we're going to run this program and we will get the same answer as expected output. So here we have the year. The printf will print this one. The year is 2012. So since %d is integer or decimal here, the var int, so var int is equals to 2012, and it will prompt as 2012, and it will continue displaying the string. The radius is denoted as so this is character, so varchar, and this is r, so this is r here, while pi is equals to float or %f. So the %f here is var float, which is equivalent to 3.1415, right? So that's how printf works. So note that the format contains almost exclusively specifiers, 3 of them to be exact. This means that you have to deliver 3 arguments for the format. In our example in the editor, this is done by repeating the same variable name 3 times. It's correct in every respect. Executing this program will output the same variable, or more precisely its value 31 3 times, once a decimal number, once the hexadecimal number, and once an octal number. As a result, the screen will show the following string. So if I'm going to run this one, it will prompt us 31, 1F, and 37. So why does it result these numbers? Since I is an integer, and this is decimal, and x %f x represents as hexadecimal number, and 31 is equivalent to 1f, and %o, which is octal, is equivalent to 37. So they have the same values but different in the number system, which is decimal, hexadecimal, and octal digits. Okay, so now let's discuss the frequently made mistakes. Let's now try to think what mistakes we can make here and what their consequences might be. We will show you some typical errors. So for mistake number 1, there are more formats to specifier than arguments. So we have the printf here. There are 3 specifier but only 2 arguments. We have 3 specifier, 1, 2, 3, but we only have 2 arguments. The last specifier is missing its argument. If your compiler is clever enough, it will pay attention to this. However, if your compiler is rather clumsy, you won't get a warning, and when you restart the program, the value printed for the orphan specifier will be completely random. Okay, so don't forget that if there's a 3 specifier, there will also 3 arguments. So for mistake number 2, there are fewer format specifier than arguments. So vice versa, and the mistake number 1, if the compiler doesn't warn you, the compilation will finish with no obstacle and nothing bad will happen during the execution. The argument for the missing specifier will simply not be displayed. Okay, so how about mistake number 3? The type announced by the specifier is different from the type of corresponding argument. So since this is a type int, but we have float specifier. So the specifier requires a float, but you've provided a variable type int. If the compiler doesn't notice the value that will be printed on screen at the runtime will really surprise you. It will have a little to do with the actual value of the variable I, which is associated with the different representation of int and float data in the computer memory. So be careful of using data type and its respective specifier. For mistake number 4, a slightly less dramatic example, you demand an int but you provided a char. So nothing bad will happen. Why? Not long ago, we said that the data type of char is treated as integer data. If you deliver the character value to the printf function but request a decimal to be shown, the printf value, the printf will output the ASCII code of the character, which was used as the corresponding argument. Right. So let's have our next slide. So be careful of those mistakes and take notes. Take note of them. Right. So one issue still needed some additional explanation. The string sent to the screen by the printf function will appear character by character, and if you don't request it explicitly, it will fill the entire line from the left to right margin of the screen or the window. So the following two invocations, the printf, this is the phrase number 1, this is phrase number 2, this is phrase number 3, will produce a continuous line, maybe span or over more than one row filled with the text. So this will get, this is phrase number 1, this is phrase number 2, and it will continuously produce the line. So we will show you a solution, try to explain the way in which works. So here, this is your phrase. So we have backslash n that represents four new lines. So the text sent to the screen will look as follows. So we have an empty line here. Why? Because we put an succeeded here, unexceeded new backslash n, or stands for new line. So we will get that. So we have input, of course, as equal important as data output is data input. Actually, it is difficult to imagine any complex program that does not require any data from the user, although you could use in this carefree way, encode all the data needed inside a source code, which is sometimes called hard coding. When you need to repeat the execution of the program with other data, you just modify the program, compile it, and run it again. This is not a particularly convenient solution. It is far better to get an information from the user, transfer it to the program, and then use it for calculation. How can the C language program can get any data from a human and store it in the variables? As in most cases, if you need to perform some complex operations, you should begin a search for the function that performs in this task, and only if such a function doesn't exist should you write it on your own. All right, so in this case, however, we are lucky the function used the data input already exists and it's easily available. So the function is named scanf and stands for scan formatted and is close or relative to printf function. And where did this relationship come from? You will see it soon. All right, so imagine that we want to ask the user about the maximum number of sheep that we want to count before the developer falls asleep. The user enters the value from the keyboard and the program stores in the specified variable, which is max sheep. In this example, an appropriate scanf invocation looks as follows. So scanf %d, and so take a look at the ampersand before the variable. Perhaps you see the similarity to the printf. The first parameter is also a format that tells a function which data will be given to the program, in which form as before. We give arguments for the format in the amount equal to the number of the given specifiers. At this point, the similarities and the difference between begin. And first, the argument for the print may be a variable. It may be an expression as well. Take a look. So here's an example snippet. Printf %d 2 times I. Here we had like to print the doubled value of I. This is feasible using the scanf specifier. We must explicitly specify the variable that is able to store the data entered by the user. This, however, is not the end of the differences. So that is how we use the scanf. Okay, look at the scanf function invocation once again. Scanf %d and maxship. Do you see the odd ampersand sign in front of the variable maxship? It is not coincidence. Forgive us, but at this stage of your education, our explanation of this phenomenon will be rather simplistic. Actually, this is a part of a more general and rather complex issue that we want to discuss later. For now, we will tell you that whenever you use the variable name in the program, we mean the value that its variable is currently storing. However, the interests of the scanf function are different. It is not at all interested in the variable's value because it will soon be replaced by the one the user enters. Scanf needs something completely different. Precisely where is the variable placed in the memory? The mysterious ampersand is a unary operator which gives information about its argument location. The scanf's format provides information about type of the data, while the ampersand along the variable name says where it has to be placed. Leaving out the ampersand doesn't cause any problems during compilation, so therefore you have to remember that scanf essentially needs it and cannot operate without the ampersand. Furthermore, the scanf format uses the same specifier as printf. This should bring you sigh of relief. Now we will show you a simple yet complete program that does work the following. First, prompts the user to enter a single integer value. Second, squares it. Next, prints the result with an appropriate comment. We assure you that analyzing this program should not be any problem for you. So if we are going to run this program, so the first thing is it will give me a number and will square it, and I will square it. So let's have 5. Okay, enter. Okay, so after that, the program will scan it, and so how to use that is scanf then %d, since this is an integer, and have ampersand value. Then we are going to square value times value. So that is the formula for square. So printf, you're giving me 5. Then printf, we are going to have the square here. All right. So that is how scanf works. Do you prefer square roots to squares? No problem, but we need to remember two things. First, there's no such thing as square root operator. Second, square roots of negative number doesn't exist. We can resolve the former issue by finding a function that knows how to compute the root. This function exists that takes an argument of type float. The result is also a float. Obviously, the square of an integer is still an integer, but the root of any number is not always an integer, like the square root of 2. The function we are going to use is called sqrt, or square root float, and requires just one argument. Oh, one more thing. To use this function, you must include a header file name math.h. We need to deal with negative numbers as well. If you're reckless as to provide a negative number, the program will just ignore you and your input completely. It may be not polite, but at least we won't be trying to bend the rules of mathematics. Whether we use the result or not, we will decide by the conditional statement. Now direct your attention to the use of floating point data and the sqrt function. So we have declared the header line stdio.h and math.h, since sqrt needs this header to run the program, or to run this function sqrt. So the first one, we have declare the function which is main, and we have the variable float and value and the square root. So the first thing that the program will prompt us is it will print or display as the given number, and I will find its square root. Okay, so have scanf, then this is a float and its value, which is stands for the variable of the uh, value of the number that the user will enter. So if value is greater than or equal to 0, 0.0, the square root, it will the value will be executed, in which square root is equals to square root then the value, sqrt then value. So printf, you have given me then printf, the square root is the uh the result. So we have a use an if statement here. So if the user will give us a negative number, it will not execute the formula or the program. So let's try. Let's have -1. Oh, one more time. Okay, when I prompt enter, it will not give us the result, right? Since we don't have any execution here. Or we can add printf, if the user enters 0, 0 or below, it will prompt us user, the value is not or find another value, just like that. So if I'm going to run this one and give a proper integer, oh, one more time, going to give 25. Okay, so you have given me 25.00 and the square root is 5. Right, so this is right. Okay, so let's have the next slide. Okay, so the scenario according to ISO 88601, many countries use year, month, date format, where year is a 4-digit number and month, which is means 2-digit number, and D means 2-digit day. Local convention can vary and sometimes include format like day, month, and year, and month, day, and year. Your task is to print values in 4 different format and check the program in the editor. So the expected output is here. So we are going to run this one. So we have experienced a compilation error. So all we need to do is to find or analyze the code inside the editor. So here we have, okay, printf. So I think we are going to delete this one because there's no such thing as this specifier, right? Okay, so and now let's check the arguments here. We're going to add year, month, and day. Okay, so I'm going to erase this. And here, month, let's erase this year. Month, day, and year. Okay, let's have day, month, and year. Okay, going to add comma, then printf gym. So this is day, month, and year. All right, so delete this one. Okay, so let's try. Going to reset the compiler and run the. All right, so now we get the expected output. Okay, so the scenario for this one is you have the data included in the code, and the three students' grade is a student A, student B, and C. Write the program to print this data in the rows. In the first row, in the header, in the format student name, first year grade, second year grade, third grade, and average. The three rows contain student name, student B, C. Right, so first year grade, second year grade, and the average of this is average, and your version of the program must print the same result as expected output. So to print this two digits of the floating point, use the point to f, the format specifier, and to fill with the spaces, you can use 9.2f format specifier, where 9 is the length of the number and the spaces. All right, so all we need to do is write the code here using the printf. So we have this one, student name, first grade, second year grade. Okay, so this is just a simple string. Okay, I'm just going to copy and paste this. Okay, right, so let's have the next row. Printf student A. So here we are going to erase this. Student A, first year grade 4.20. So here, going to erase this and replace percent .2f, and another one %2f here, and third year grade another one, and so on. And we'll write the argument, which is this one. Oh, sorry. So this should be we haven't declared any average here, so we are going to declare average, and the average is average. Okay, let's have float. It should be named as avg. Okay, so let's have average one, and we are going to have this. So how to find the average is, all we need to do is sum it up and divide it by 3, since they have 3 values. By 3 and semicolon. Okay, so we are going to copy it and paste it within average 2 and 3. Okay, so this is B, C, B, and C. B and C. Great. So all we need to do is have 9.2f here. Okay, and then let's add the argument or the variables used here. Then and then what do you think? It is average one. The right average one or average one. Alright, so before we continue and copy paste the printf student B and C, we are going to check if that's right. Forgot the semicolon here. Okay, let's do it once again. Forget also another expected. Okay, sorry, forgot. It's the showing. Okay, here. Right, so now let's check. I think this is all right. So we don't have. What do you think is missing? It is \n for a new line. Okay, let's try it another one. All right, so we have an excess spaces here. How about this one? All right, so now it gives us a good alignment. Okay, let's copy and paste this 2 times. So this is B. This one is 2. Forgot this is capital B. Be careful of the lowercase and uppercases of your variable. So this is B. How about this one? Okay, so let's have 3 and C. And C. And C. Right. So I think we all oh, sorry. Forget the new line again. New line. Okay, so let's reset the console and let's run this program now. Let's check if, all right, so 4.23, 4.5, 40, 4.335. All right, so now we get the correct answer. Okay, here's another laboratory example. So the scenario is write a small program which prints a figure like one expected output section below. Your version of the program must be printed in the same result as expected output. Remember, if you want to print as a backslash character, then you have to escape it like this, double backslash. So how to print that? Um, So all we need to do is copy this one in the first part. All right. Then let's have the new line. We don't have any variable. We don't need any variable here. So just take a look at the spaces. And let's have the second line. So where's the backslash here? So here we are going to make it double. Okay. Let's double this one. Right. So here's another one. Let's have the third line. Going to copy this one and paste it here. Okay, going to remove one space and add escape here. Okay, so let's have the fourth line. Let's have the fourth line. All right. So just copy and paste it. All right. And how about the next line, this one? Okay, just copy and paste. Okay, so where's the backslash? This is the backslash. We are going to remove one space, then add backslash. And then how about the second to the last one? Okay. Oh, forgot to. Okay, here. So paste it and another backslash. Okay, and the last one. Okay, let's have printf equals, sorry, then v, forget to add backslash n for the new line, right? Backslash n, let's put backslash n here, backslash n, oh, sorry. Okay, let's try to run this program. Oh, what do you think is wrong with this? Oh, this one should be placed after the bracket. Okay, another one. All right, so now we got the right answer, the right output. So here, the scenario with the right of program which takes two values, account of the days in a 1 week, and the value of pi. Next, print the two values, then forget about the data types. Your version of the program must print the same result as the expected output. Okay, so the first thing that we are going to do is print f, and then how many days in a week? How many days in the week? So here's the question. Wait, so all we need to do is have the scanf and provide the variable. So days, we are going to declare the variable here, days. Okay, so here's f. This is a decimal, so %d, then ampersand days. All right, so the next one is the value of pi is 2 point. So all we need to do is just declare the pi to its value, which is 3.14. Okay, Then the value of pi to 2 points is, all right, so just let us print just like this one. We will prompt the user to enter the value. Okay, so value in pi, value of pi in 2 points is, then let's have pi. We're going to erase this because the user will give us the answer. So there are 7 days in a week and pi value is okay. So here, this is the sample output. Okay, I'm going to have the printf for printf here. Printf how many days in a week, and then we will say it is 7, then percent d, and we will have days here. And how about the next one? The value of pi. Okay, here is percent d again, since it is an integer, and let's have pi. Okay, the third is there are 7 days in a week, so we are going to make this 7 into a specifier, which is d, and that is days. Another one, and the last printf would be pi value is, so this is a float. Sorry, this is a float. Going to erase this and add the specifier, which is percent %f, and that is equals to pi. All right, so let's have how many days in a week. So the console is asking me, I'm going to answer 7. Value of pi is 3.14. Okay, let's try it once again. 7, then 3.14. Oh, this compiler is too sensitive, so be careful and just reset if it is not responding. 3.14. Oh, like this one. We're going to 7. All right. Oh, forgot to add \n for the new line. Another one. Okay. Let's have 7 and 3.14. Okay, how many days in a week? 7. All right, so now we get the right answer. All right, so here's another laboratory activity. So write a program which records 2 float values. Next, print the sum, difference, and the multiplication result of these 2 values. So all we need to do is create a 5 integers. So all we need to do is, since this is a float here, value 1, value 2, then we have sum, difference, and then the product. Okay, so all we need to do is have the printf and prompts the user to enter the 2 values. enter value 1. Okay, then we will have the scanf, of course, to store the data or the value that was entered by the user. So since this is a float, then we will have the specifier %f, and then we will have ampersand, what do you think, v1. All right, so let's copy and paste it for the second value, and we will have the value 2, and this is also a float and v2, and then it will prompt us the result. Okay, so print. All right, so before that, we are going to create a formula for sum, difference, and product. So all we need to do is a sum, then v1 plus v2, then diff is equals to v1 minus v2, then we will have product equals v1 times v2. Okay, so we are going to print now the result. So the first thing is to have the 5 point, which is the value a percent f. So let's have addition and percent f again, then it will prompt us the sum, which is also a percent f. So all we need to do is have a comma and add the arguments, which is v1, v2, and sum. Okay, so now it's time for us to do the remaining. This is minus, this is diff, this is multiplication, this is the product. Right, so we are going to run this program, enter value 1. So if I'm going to enter 5.5, oh, 5.5, then 5.6. All right, so forgot again the new line. So sorry about that. Okay. Let's have a try again. Enter value 5.5, then 5.6. Oh no, this compiler is you need to input the value in a faster way. Okay, so we have our answer. Okay, so now let's have the part 2. So for this scenario, write a program that asks the user for a day and month, separate integer values for both. Next, it should print the day number of the year for the given day and month. Assume that the year is a leap year. February has 29 days, and your program must print the same result as the expected output. So here's the expected output. The day of the year is 1. And the day of the year is 31. Sample input is 29, then 2. So all we need to do is from the user the day and the month. Okay, so here we're going to declare integer for month and day, and then printf enter day, and then scanf. Since this is an integer, we are going to use what specifier. This is the for decimal, and then ampersand d. Okay, so we are also going to ask the user enter the month in number. Okay, so this is the month, and the output will prompt us the day of the year is percent d, put the d. Okay, so as you can see, on the sample output, we haven't used the month here, only a date. So, okay, so as you can see, we are going to enter 31 and then number 1 and then, okay, so we have the same output here. How about part 4? Okay, so write a program that prints the name of the given day of the week. Your program must print the same results. Expected output. This task is similar to the previous lab, but this time you have to get the day of the week from the user and validate the input. Test the program for all the days of the week. Add to code to print. Okay, so this time we are going to use if else. All right, so we haven't discussed it yet, but I'm going to show you how to do that. So the first thing is to declare the day, and you will have printf enter the day of the week in numbers. Okay, so we will have the scanf, and then since this is an integer, we will have the percent %d and ampersand day. So if day is equals to 1, then it will print the day of the week is Monday. And then else if day is equals to 2, then it will prompt us the day of the week is Tuesday. Okay, so let us do that 5 more times. Okay. 1, 2, 3, 4, and 5. Okay, so let's have this is for 3, that is for Wednesday, and 4 is for Thursday, and 5 for Friday, and 6 for Saturday, and 7 for Sunday. Okay, so now let's try our code. Okay, enter the day of the week. So since this is Thursday, today is Thursday, I'm going to enter 4. So today, the day of the week is for Thursday. So we got the right answer here. So we use a conditional statement code if else. Okay, so let's have the last laboratory activity. This is the part 5. Okay, so the scenario for this one is write a program that asks the user for a day, month, and year. This is a different integer values. Then next, it would print a day number of the year for the given day, month, and year. This task is similar to the previous lab. So here, so 1/1/2016, day of the year is 1. Okay, so here, sample output 31, 12, 2015. The day of the year is 365. So that would be the last. Okay, so okay, this is not, since the previous code that was written here is not related to the instruction, so we are going to write our own code here. So enter the day, and let's have the scanf %d and month and day and the year. I mean, okay. So we are going to create a formula in order to count the numbers of the year, the day and the year. All right, so I write here a sample program for this scenario. I have declared the month, day, year, and the day today, and I will also declare the number of months in every in the number of days in every month. So, for example, initially I declared for month 1, this is January, and that is equals to 31 days. And the program will prompt us to enter the day today, and then enter the month, and enter the year. So if month 1 or January is equals to a 1, or the so if the user will input 1, then the day is equals to 1, which is equivalent to the day is the day. All right, so did you get it in numbers? So if I'm going to run this program, so enter the day, for example, since I don't have any option for February to December, I'm going to write here, enter the day, which is January 31, 2019. Okay, so number, and oh, one more, 31, 1, then 2012. So the day of the year is 31. Right, so if I'm going to write here, just wait for a minute, I'm going to write here the and 2, which stands for February, and we are going to consider the leap year, which is equivalent to 29 days. M2, M3, March is equivalent to 30 days, and month 4 is equivalent to 30, which is April. May is equivalent to 31, 30. January, February, March, April, May, June. So this is 31. And month 6 is June 30. July is equivalent to 31. M8, which is August, is equivalent to 31. September is equivalent to 30 days. October is equivalent to 31. And November is equivalent to 30. And month 12 is equivalent also to 31. So all we need to do is add here else if. So I'm going to copy this one and add else if m is equivalent to 2, then day plus, since day is the day, then plus m2, I mean m1, because we have we are already done with the previous month, which is m1, and so on. Okay, until December. I'm going to write this example, this else if condition. I'm going to add m2 and also m1, m3. Going to copy paste this until December. So this is 5 plus 4. Okay, another one. M5. Okay, we are already done with until May. Okay, let's have June, July, 6. Then 8. This is August plus M6. Okay. Okay, now we are going to September. September plus M8. And now let's have October. Okay, how about November? Okay, 2 months more. Let's have M10 plus M. Okay. And lastly, we will have December. So if M is equals to 12, then we will add M10 and November, which is M11. So if I'm going to enter the last day of the year, let's check if it's 365 or 306. Oh, else previews, else if, else. Okay. It will always depend on the compiler. People get the okay. We are expecting the M11. Right, so guys, the error in the compilation error, I just noticed that we need to add curly braces inside the if else statement inside after the parenthesis, right? So we add curly braces after that, another, and if you're going to run this program, and I will input the last day of the year, since we consider that February has 29 days. So we assume that we will get the value of 336. So here, okay. So we got the final answer. The day of the year is 366. All right. So now let's have the next one. All right. So this is the module 2 quiz. All right. So please answer module 2 quiz, and after that module 2 test. Right. So in this session, we will end this session, and please continue the answering the module 2 and module 2 quiz and module 2 quiz. So this concludes our second session, part 1 of the Diverse Node Mobility Front-End Development Program. Have a good day, guys, and good luck.